is my extended elevator speech for the, okay, cool.
Yeah, you just can tell us, you know, your name, kind of where you're from, and just if your story, if you have a special story about your journey here and how you got to your research, or just tell us a little bit about your research. And if you feel so inclined, you can share if it seems important why the ARCS award, what that might have meant to you when you received it, in your decision to come, and then if you know who the donor, if you have special name donors,
Okay.
You can share that as well.
Yeah, perfect. All right, my name is Gabriela Tosado. I'm from Miami, Florida. I went to the University of Miami for my undergrad, where I majored in chemistry, environmental policy, and religious studies. And now I'm getting a PhD in none of those things. Instead, the past 4 years, I've been working towards my PhD in chemical engineering, creating new solar energies, new types of solar energies. So the idea with my research is creating solar inks. We have the silicone rooftop panels, but there's an affordability cost that prevents the transition away from the fossil fuel economy. And silicone, you have to melt it down, you have to shape it, it's brittle, there's expensive protection, expensive implementation. But with the solar inks, called perovskites, that's the name of the material that I work with, you have the ability to instead print them out like newspapers, roll-to-roll printing style. And I mean, we print millions of newspapers a day for like pennies a sheet. So when you have this ability to print out solar panels, this reduces the cost substantially and would help a lot of people with affordability. Now, my perovskite materials, the perovskite world, has been able to reach efficiencies similar to the silicone rooftop panels, which is great, but they are still in the research setting, which means there's something that's not fixed yet. And with perovskites, that's toxicity and stability. So the most efficient perovskites have a lead-based center, and the perovskite material degrades over time when exposed to water. So nobody's gonna want a water, lead-soluble panel on top of their rooftop. So my research is replacing this lead center with instead tin, which is non-toxic, completely fine. And tin has a very similar electron configuration, so we could replace it and it still functions as a solar ink. So it still has that printable process, which will make solar energy inexpensive. In order to improve the performance still, because the tin-based ones aren't as groundbreakingly efficient as the lead ones, and also to improve the stability, we've been doing surface modifications to kind of protect them from the water attacking the composition. We've also used these modifications to help transport the electricity more easily to improve the efficiency, and kind of been tinkering around with some components that are more resistant to water. UW has recently opened up these super cool test beds that have the solar printer that we're going to try large-scale testing on, so that's super exciting. But for my future plans, when I do graduate, my time here has kind of shown me, although you do need to develop these solar technologies, there's also a policy component that needs to be addressed. So I'm going to apply for the AAAS Fellowship, which places PhD graduates, experts in their fields, in areas of policy, such as the National Science Foundation, analyzing the legitimacy of grants, or as an expert consultant for members of Congress. So I want to use my expertise in solar energy to try to push for factual science-based policy that I think we desperately need to help transition us to a clean energy, to a clean energy economy. For this fellowship, what it's meant to me personally was, even though there is the financial component, I mean, I wouldn't have been able to move here without that part or afford living here. What's really affected me more personally was the support system. Knowing that there's someone here, a group of people that want me to succeed and that I will be able to lean on when necessary. So for example, when I first got here, it was like day 2 at UW. A fellow first-year colleague of mine in my department decided it was necessary to inform me that I was only picked because I was a Hispanic woman. They needed to check a box off an NSF grant. Yeah. And so I'd never run into that logic before because Miami is all Hispanic. That just didn't come up. And so that really kind of chipped away at my confidence. I'm like, oh, I was only a chemist for undergrad. I wasn't an engineer. Could that be true? Is that true? And so it kind of always in the back of my mind. But when I reached out to Jan Harrison, who's our ARC's den mother, and spoke with some of the sponsors and the people at my department who nominated me for this in the first place, it was good to be reminded that no, you are here because you earned the right to be here, and we see potential in you to do great things for the community. And the year after, my research got an NSF fellowship, and his didn't, so. But anyways, the support of ARCS has really been just really important to me during my career here. And so I would like to thank Elizabeth Rudolph for her support and the ARCS team for supporting me in my PhD.
Oh, that's wonderful.
Thank you.
Elizabeth Rudolph is my sister-in-law.
Yes, I know.
Okay. That's great.
So thank you.
Very good. So I don't know if all of you haven't done all this before, but we can ask her questions.
Okay.
We do. I have a question. What does ink mean? Is it INC, like incorporated, or just what is
Oh,
it?
it's like printer ink, like the
INK.
toner, like pen ink.
So it's INK.
Yeah, it's like,
I wrote it.
I mean, if I draw just the ink.
Yeah.
Solar.
But it's not really ink that you're dealing with. Why do they call it ink?
Solar.
Because it works the same way where you could put it in a printer and it prints it out like ink.
So you put the tin and all,
It's a liquid, yeah. it's like a
and then
black
it
liquid.
goes in and it gets this solar
Yep.
bonding like an ink
Mhm.
on it.
Yes.
Oh, interesting.
Yeah, and then you anneal it, so you just heat it up to dry it, and then it's good to go.
Wow.
Yeah,
Yeah.
very simple.
Can I ask, could you tell me the name of the molecule again?
Perovskite.
And is it something that was synthesized?
Yes.
And how long ago can you tell me more about that? And
Okay,
and
so
How
the
do you spell it, please?
Yes.
Perovskite.
Thank you.
So now,
That's the molecule that's the ink.
yeah.
You can see that some of us are scientists and some of us are not.
I'm not, so
I don't know that there's another, you're not a scientist. Oh, you are.
I'm a
Science
liberal arts and
background,
science
yeah.
major.
Okay.
So the perovskite actually refers to a type of structure that's existed for a while, but no one's ever tried it as a solar material before until I think 6 years ago. So it's pretty new stuff. So everyone's super excited. They're like, oh my God, it's so efficient. But there's still these issues of toxicity and stability that people are trying to address.
So the lead is what's toxic, not the perovskite.
No, just the lead. It's just one single part in the perovskite composition.
Yeah.
And now you're trying it with tin instead of lead,
Yeah.
and still need a coating that will work in wet weather.
Yes, because I mean, Seattle's pretty wet.
Yeah.
What kind of a printer do you print on?
So
Because we have 3D printers now. Do you require 3D and
No.
creating a?
it's pretty much similar to the newspaper type printer at the
Okay.
solar test beds.
Mhm.
Right now, our perovskite, since we've been working with stability and compositions, have been like test samples where we
Mhm.
test a bunch of different, they're like yay big. But the solar printer is pretty decently sized.
Interesting.
So one of the things I liked, and you presented a goal in your presentation of having scientific-based evidence driving some of the progressions that you're working for. And, I'm trying to think about all of this because I've never analyzed this myself before. I've just listened and enjoyed. But I think that the structure of your presentation is as important as the structure of perovskite. for people to hear, I'm just babbling, I'll come to a question maybe. To hear the bigger vision of why you are motivated, and why, you know, I mean, I like environmental things, but I really like the fact that that's really important, and I assume that works for those of you that heard it before, is to really focus what motivates you as a scientist in bringing something new to the market.
Yeah, so I wasn't sure if I should put this in my elevator speech, but like one of my main motivations is I am from Miami, and we have a lot of consequences with global warming being thrown at us. We have the rising sea levels, we have those larger hurricanes and storms that are happening. We're usually like right on the forefront of those. And we're the Sunshine State. We should be the leader in solar energy, but we're not, which I think is ridiculous on many levels. But so it's kind of motivates me as a way to protect my own home. Like, I need to at least contribute my small part to these solutions, because my family will be personally affected very quickly. It's like Florida's already affected by climate change.
That's great. So you still have family there?
Oh yeah. And I also didn't know if I should mention this. It's a different side project that's related to my research, but we work in Puerto Rico, kind of tailoring the two of energy and health. So we create, after Hurricane Maria, Puerto Rico didn't have power for 6 months to almost a year, depending on where you lived. So we created these solar systems with batteries to power medical devices, because a lot of people that rely on like air pumps or oxygen concentrators didn't have what they needed in terms of electricity for a long time. So we went to Puerto Rico a few times.
Who's we?
Oh, me and Professor Pozzo and a few other students.
So a group from the U?
Yeah.
Okay.
So this was sponsored by the University of Washington, this
Yes.
project?
The Clean Energy Institute sponsored it, and we did some fundraising, so I think there's a few other smaller things.
Oh, wow, cool.
Yeah.
I think that's fabulous. The
Yeah.
concept of here's my research,
Mhm.
here's it immediately, you know, the bigger picture was these printer
Yeah.
things, but look, you taking the skills that I've gained in my program, and we are making a
Oh, exactly.
Already made an impact.
That must have been
impact and
exciting.
changing
It
lives.
was very exciting. I wasn't sure whether to include it though, because it's not perovskites. We're definitely using commercialized cells for those.
Well,
But
we're just getting to know you, so it's whatever information.
Right, there's no
Yeah.
limits now, and
On your time.
I mean, I remember what last year did a little bit, but other
Yeah.
than that, I don't know. And they talked about the research, and then they talked about their volunteer work
Yeah.
somewhere.
And that was a process. That wasn't something we necessarily learned from the first meeting.
Right,
Yeah.
but I really like that, because I think those were more disconnected to the research, or not necessarily connected. It didn't, you know, I don't remember what they did, but I really like one that is, you know, I've learned something and I get to put it into action, put
Yeah.
it into health improvement
absolutely.
today. So
Yeah, I agree.
that's
Mhm.
really good. And then your part about why ARCS, that was very significant the way you said it, because a number of people will talk about the financial underpinning that it permits, that, you know, allows you to do some things, because it doesn't tell you how to spend it. But I thought the fact that community is as big an asset as the financial support. So.
Yeah, I try to talk about that as much as possible, because a lot of students in PhD programs do face imposter syndrome at some point in their life, where someone, especially minorities, someone tells them that, oh, they didn't really earn their way here, even though of course they did. They probably had to overcome more barriers just to get here.
Yeah.
And so I try to put that story out there as a way to be like, no, you're not by yourself. This does happen. It should be talked about more.
Yeah.
Back to what you're doing. So, solar energy research is certainly probably done all over the country. Is what you're working on at the University of Washington unique, or is this same kind of research being done all other places, and are you collaborating, or what do you
See,
know
I don't
about
know
that?
why Seattle is really good at solar energy research, because every time I talk about that, they're like, but Seattle's cloudy. I'm like, well, we're not outside. The lab isn't just in the street. But like, we've invested a lot for the lab space. It's very unique to UW. Like the test centers, I think there's only 3 similar in the world, and I think this is the other one. I think is in Norway, and one of the other ones is in Asia. So this is like one of the best places for solar research.
Is that why you
That's
chose
very
the
cool.
University of Washington?
Yes, it is. Especially because when I came here for recruitment weekend, the Clean Energy Institute was just opening up, and I was
Oh.
excited to be able to get on the ground floor of
Oh, well,
that.
that's exciting to hear as well.
Yeah,
Yeah, I think that's important.
it was really cool.
Because I just immediately think, oh, well, there's probably this kind of testing, this kind of research is being done, probably, in California too, why is it more important here than there?
Like a lot of people are working on perovskites. Less amount are focusing on the toxicity because everyone's excited by the efficiencies, like record chasing. I don't need to chase records. It's already good enough. I focus instead on stability and toxicity. But UW is one of the few places with like the equipment in the lab and the printer that we do have. So we're excited to start dabbling with that.
For somebody who knows nothing, tell me what it's the relationships like between you, the PhD candidate, and your professor.
So it definitely depends on the professor. For my professor, it's very back and forth. So if I have an idea I want to pursue, she's like, okay, go ahead. And if she has an idea, she tells me about it. I'm like, cool, I'll test that. Great. So I enjoy a relationship. But I've definitely heard some horror stories of professor-student relationships. I'm glad that I do not experience that.
Who's your professor?
Professor Yu, Chiu-Ming Yu.
And is that YU?
Yes.
Well, Mariah, I don't really know what our timing is and how long we're able to sit and chat,
We
because
have-
we can visit with her forever.
We have 30-minute sessions, but I don't see that the next one's here. So
Okay.
But you were probably only planning to be here till 2:30?
Oh, I'm good.
All right, well, I didn't
Tell,
want to.
tell me about a typical day you have.
Okay, so typical day, like research-wise,
Yeah.
Yeah, that's it.
I mix my ink at our department under a glove box. So that's a little nitrogen atmosphere box because it is sensitive still. So we want to remove the things that make it unstable until we could test stuff. So I make my little ink. I go to the Photonics Center to create the little device, which is spin coating because we don't have a printer in our lab. So we spin on the ink and then we dry it. And I evaporate electrodes, so we have like the metal contacts. I change something, I have some variable I'm testing, I implement that, and then I test it with the solar simulator, which is pretending it's a tiny sun that's controllable instead of walking outside, because every day you're gonna have a different sun amount. So we got a tiny little solar simulator to test our device's efficiencies and like other parameters to compare to other labs, stuff like that.
Cool.
Yeah.
Cool. And then you did say you would like to go hiking. Have you been hiking?
Oh my God, I've been everywhere. It was a struggle though, because Miami is flat with no
Right.
mountains.
Yes.
So it was definitely a learning curve for the hiking. But I have gone a whole bunch. I actually went last weekend Rattlesnake because I really wanted to see it covered with snow. And it was
Ah.
really beautiful, like the frosted trees.
Wow.
I love snow.
Me
I
too.
love controlled snow where I could drive to Seattle and there's no snow. But if I want snow, I could find it.
And you know this was, well, you've been here long enough to know this was unusual.
Yeah.
So it's what Mariah or Thomas or Elizabeth put down here as for what your research is not what you're doing.
That was her original bio.
Yeah.
So basically I pulled the first year
Yeah,
bios.
from your original bio.
Because the first year we weren't put in our labs yet.
Yeah. So that you had an interesting way to get here too. Because it says you were studying abroad in Iceland and contributed to glacial recession research and modeling and all of that. So that's interesting too. But I'm really glad we were able to hear about what you're really doing now.
Yeah.
We'll have to just remember that. I'm glad we recorded it, or maybe if you have a more recent bio too.
I
on
could
your
update
research.
it, no
Yeah.
problem.
But we can talk about that later. But yeah, thank you. That was very.
Are we through or do we get